Hi, today we are going to study recurring decimals, and I'll talk about what they actually are in a minute. To start off with, I want you to have a go at writing the following as decimals without a calculator. So can you remember how to write 1/8 as a decimal? Do you know what it is? Have you learnt it, or how do you have a way of finding it? Okay, so pause this video now and have a go at these three. All right, I'm going to go through these. So, you might over time just, that 1/4 is 0.25 and 1/8 is going to be a half of that. And so it's going to be 0.1, and then you're going to half this 5-bit, and that's going to become like 2.5, but it's going to become 0.125. That is something that you can just learn. If you didn't know that, then okay, we're going to need to do short division. So we're going to do 8s into 1, 0. But we can do 1.00000. We can just write that as such. And then we can use the short division method and cross this out and move it here. So it becomes 10. Then we do 8s into 10, 1. Remainder 2. 8s into 20, 2. Remainder 4. 8s into 40, 5. We are done, okay, because there's no remainder, so I don't need these other zeros here. So that's another way of getting 0.125. This is a technique that you are expected to be able to do. You would have been doing short division, presumably for a good amount of time, and quite possibly involving fractions before, but this is just a recap if not. Okay, let's do 1/9. So yeah, let's do 1/9. Okay, you may know what 1/9 is already, or you may not. So let's assume not. Then you do 9s into 1, 0. But then again, we add our zeros here. 9s into 10, 1, remainder 1. 9s into 10, 1, remainder 1. 9s into 10, 1, remainder 1. This is going to go on forever. It's not going to stop. And what we are going to get is 0.111111. I'd have to keep writing it forever, but I don't. What we do is we introduce some notation. We say 0.1 with a little dot above it. 0.1 recurring. There we go. If that means, this bit here means 0.11111. And on your calculator, there is a button that does that if you want to try and find it. And that allows you to put it in to your calculator. Okay, right, last one. Oh, let's jump ahead actually. So this here stops. It's called a terminating decimal. Whereas this 0.11111 does not stop. What do you think that might be called? Recurring decimal. Goods. So we've got these two types of decimals. And actually there is a third type. So something like pi is 3.1415926 and so on. This actually also goes on forever, but it doesn't recur, it doesn't repeat. And this, I suppose this just comes under the irrational number definition. It doesn't have quite the same, like we normally say recurring decimals, terminating decimals. We don't really have a name for this other than to say it's an irrational number, because any irrational number can't be written as a fraction, and I think any fraction will either be terminating or recurring. Okay, last one, 1/7. Have a go at this one if you've not already. This one's got a really nice result. Okay, the result is, right, so we're going to do 7s into 1. Now this time, I've done these other ones quite quickly, but let's imagine we don't know our 7 times table. Well, then what you need to do is you need to make a little list of 7 times 1, 7 times 2, 7 times 3, 7 times 4, 7 times 5, and so on. Okay, keep going, because this, we can still use this if we didn't know our times table. If we were dividing by 17, for example, you'd have to do that. So let's keep going. 6, 7, 8, 9, and 10. 42, 49, 56, 63, and 70. Okay, we're going to use that now. So 7s into 1 don't go. Put a point there. 7s into 10 go once, and you can see remainder 3. Put that on the 0. 7s into 30 are going to go 4, remainder 2. 7s into 20 are going to go 2, remainder 6. 7s into 60 are going to go 8, remainder 4. Sorry, bear with me. 4. 7s into 40 are going to go 5, remainder 5. We don't have a repeating pattern yet, so we have to keep going. 7s into 50 go 7, remainder 1. 7s into 10 go 1, remainder 3. And you can see at this point, because I've got a 1 here and a 1 here, actually the pattern is now gonna carry on. If I just remove these, it must follow the same pattern and go 1, 4, 2, 8, 5, 7, 1, 4, and so on. This is another recurring decimal, and we can write it like so. We can write 0.142857, and then we just put dots above the start and end of the pattern. Okay, I hope that makes sense. So practice some more if you want and check with a calculator, but that is how you can write a fraction as a decimal, okay, using short division. Okay, we have briefly looked at writing any fraction as a decimal, and I've said you either might be able to do it through recognition, but it is important that you can use short division to work it out as well. We've also talked about how some terminate and some recur, they go on forever. We use these little dots to show what part is going on forever. Because, for example, you could have 0.123 with just the 2 and the 3 going on forever, and then you would put it like that. Or you could have 0.1203, and this bit here then repeating, so 203, 203, and then you would put your dots like so. Okay, what we are actually going to be focusing on today is the opposite of what I've just shown. So not going from a fraction to a decimal, but from going from a decimal back to a fraction. If I have 0.32 recurring, 0.32, 32, 32, 32, so on, how can I write that as a fraction? This is one of my favorite topics, I think, at GCSE, because it links, you wouldn't expect it. This looks a very difficult problem, but you can bring in algebra into our number to actually solve it. So this is how we're going to do it. We are going to so this is going to be example 1. Let x equal 0.323232 and so on. What I'm then going to do is I'm going to multiply it by 100. Okay, so 100x equals 32.323232 and so on. And if we now look at what is happening, I've got the same thing in each of the decimal places. That's why I've times by 100. If I times by 10, then I would have got 3.2323, and they would have always missed by a little bit. So that hopefully explains why I multiplied by 100. What I'm then going to do is I'm going to take my 100x and I'm going to subtract x from it. And then I'm going to write it. So I've got my 100x, 32.3232, and so on. And I'm going to minus my 0.3232. And what you can see straight away is that they're just going to cancel. I did sort of imply this before. So I'm going to get that 99 of my x, which I don't know, that's what I want to find, is equal to 32. And that's going to mean that x equals 32 over 99. And I've managed to use algebra to help me write 0.32 recurring as a fraction. What you will find now, if you say, you could just try some out. You could put some into your calculator. 23 over 99. Okay, what is that equal to? That's equal to 0.232323. If things are repeating by 2 digits, like so, they will always be divided by 99. Now, I say this to kind of, shed some light on it, but I don't want you to just learn. I don't want you to just say, right, this is going to be 32 over 99. You need to have this method sorted. You need to show you're working, and we are going to look at more difficult examples. I'm going to keep them as an extension today, but they are important. Okay, let's look at the next one, 0.154 recurring. What do you think we might do here? If you're confident, I'd ask you to pause the video and try both of these and check with a calculator if you're right. Otherwise, I'm going to continue with them. Okay, so question 2. We're going to let x equal 0.154. It's recurring. So it's going to be 154, 154, and so on. Now this time, what am I going to do? If I multiply by 100, the digits are not going to line up. I'm going to multiply by 1,000. And that's going to give me 154.154, 154, 154. Okay, I've shifted the decimal place. And this time you can see it's going to cancel in the same sort of way. I've got my 1000x and then I'm minusing x, same procedure, 0.154. Okay, and these go on forever. And these bits are going to cancel. I'm going to be left with 999x equal to 154. So x will equal 154 over 999. Check with your calculator. One thing you should do is you should always try and simplify it. In a non-calculator scenario, you'd have to find factors of both. In a calculator scenario, you can just chuck it in and your calculator will simplify it. But make sure you look for factors. Now this is quite. How do you look for factors of both 154 and 999? Well, you might try 11, but that very quickly doesn't work. You might then try 9, but remember the 9 will go into this one. So I'm choosing 9. I'm choosing 9 and 11 because they both go into the bottom number, but 9 doesn't go into here. How do I know? Because the digits add to 10, and they must add to a multiple of 9 to be divisible by 9. Okay, let's just finish this off. So the third example is to 0.1234 recurring as a fraction in its simplest form. So what I'm going to do is I'm going to let x equal 0.1234, 1234. This time I'm not going to multiply by 10, by 100, by 1,000. I'm actually going to multiply it by 10,000. So it's basically this. It's always going to be the same number of If there's just one thing recurring, it's going to be 10. If there's two things recurring, it's going to be 100. Three things recurring, 1,000. This is going to be 10,000. You'll recognize this through practice, but I'm just letting you know. So we're going to get 10,000x will equal 1234.1234, and so on. We're going to subtract those. So I just need to create a bit more space. So I've got my 10,000 x minus x 1234.1234, so on, minus 0.1234, so on. These cancel. We're left with 9,999x equals 1,234. X equals 1,234. Okay, very nice method for working out how to turn a recurring decimal into a fraction. Again, in this case, it doesn't simplify. That is our final answer. It gets a little bit more complicated, but before I go into that detail, I would like you to have a go at this cross number. So please pause the video and I'll send through a file for it. I want to see full working. You might know what the answers of some of these are by the pattern that's going on, but remember, you do have to simplify them, and some of them will simplify. And then pause the video and have a go now, and I will show the answers in a minute. Okay, hopefully you've had a good go at that task, and here are the answers. So you put the fraction in between, that's what I wanted, and then the numbers will go in like so. And there's some really nice sort of answers going on and simplifying down, but hopefully that makes sense. An extension is so recurring decimals is to write this recurring decimal as a fraction. Now, this is going to be a bit trickier because only the 4 and the 5 are going on forever. So we can't just write it straight down. We're going to need to do a calculation. We're going to need to try and simplify it. Okay, and using non-calculator methods for this. So we are going to do exactly what we did before. Let x equal 0.245454545. Okay, there are 2 bits repeating, so we are going to do exactly what we did before. Because there are 2 bits repeating, we are going to multiply by 100, and that's going to give us 24.5454545, etc. Okay, ... This is still okay. I don't have these two the same, but from then on, they will line up in exactly the same way. So I'm going to do 100x equals 24.5454, etc. And I'm going to minus my x. So I'm going to minus my 0.2454. And these are going to cancel. And what I'm going to be left with is 99x equals 24.3. We're nearly there. X equals 24.3 divided by 99. However, we always try and simplify fractions and get rid of, we don't want decimals in our fractions. So what can we do? We can multiply top and bottom by 10. 244 divided by 990. So this is not following the same thing as before, this 99 idea. Okay, we then have to simplify it, and actually because 9 goes into here and goes into here, you can simplify it and divide through by 9, and if you do so, you will get to 27 divided by 110, and that's the simplified form. So I'm not going to do any more examples on that. It's just like a little bit extra to recurring decimals that you should be aware of. And here are some questions to test you on it. So on the left, I've got some recurring decimals. On the right, I would like you to write down the fraction that you get. So only parts are recurring, as you can see, but use the same method as before. Please pause this video and have a go now. All right, let's see how you did. I'm not showing my working, but here are the answers. So check that you got them. These have been simplified. You must try and simplify them as much as possible. I've written this one as a mixed number because it was written as 5.2 recurring there. Okay, one more task for you, if you've got onto it, is to have a go at these questions here. So I can add recurring decimals together. I can divide recurring decimals. How can you rank the following answers to the sums, to the arithmetic, in order smallest to largest? You're going to need to find the actual fractions for each recurring decimal, get a final answer, and then try and order them. Okay, so please pause this video and have a go now. All right, what you should have found are these for A, B, and C. So once you've got the fractions, it's not too difficult to then order them. So we can see that this one, because this one's top heavy, C is going to be the largest. So C, which is 4/3, is going to be the largest. Now, to compare the other ones, you might want to put them over a common denominator. So if I want to compare 2/3 with 5/9, then I can multiply the top and bottom of this one by 3 and get 6/9. So I can see that D is going to be 5/9 is going to be before my A, which is 2/3. Final question then is just this 3/4. Well, 2/3 is actually 0.6 recurring, whereas 3/4 is 0.75. So I can see that actually 3/4 is going to be the one that goes here. Okay, so hopefully you did all right at that. Well done on recurring decimals.